Hello, I'm Bakhtiar, a physics teacher from Kuching North Science Secondary School in Malaysia. Through this video, we are going to study some concepts on forces and angles. Let us watch this scene. Adam seems to have difficulties in dragging the rubbish bag. Now, why do you think Ali is not having difficulties dragging his bag? Experiment with your friends and see why Adam is having difficulty in dragging the bag with these materials. Now, assume that the uniform wooden block provided to you by your teacher represents the rubbish bag. Attach one end of the string to the wooden block and the other end to a spring scale. Drag the wooden block along a smooth surface by pulling the spring scale. Try to keep the angle of the string with respect to the ground as constant as possible and record the reading on the spring scale. Then, repeat the procedure but with different angles with respect to the ground. At which angle did you find it easier to drag the wooden block? Please report your findings to the class. See you in a while. Earlier, you were asked to find out why Adam is having difficulty dragging the rubbish bag. Through the experiment, you were asked to drag a wooden block at different angles with respect to the ground. What have you found out? Yes, you are right. It is easier to drag a wooden block with a smaller angle to the ground. Now, let us observe another scene of a child sitting on the flat area of the playground slide and then sliding down along the inclined plane of the slide. Have you ever slid down a slide before? Do you move downwards when you are sitting stationary at the flat area at the top of the slide? What would happen to you when you sit on the inclined plane of the slide? Now, with reference to the slide, when would a wooden block start to slide downwards if it were placed on a tilted plywood? Let us find out in the next activity. You will be given a piece of plywood, a wooden block, and 7 to 8 pieces of bricks. Now please work together in a group of 4, plan and carry out an activity to investigate what would cause the wooden block to slide downwards along a tilted plywood. You will also have to answer these questions. Question 1. How can you make the wooden block accelerate at a greater rate down the slope? Question 2. What causes the wooden block to accelerate at a greater rate when the plane is being tilted? Question 3. How do you think this happens? Now back to the questions earlier. Question 1. How can you make the wooden block accelerate at a greater rate down the slope? Yes, the wooden block can be made to accelerate at a greater rate by increasing the angle of inclination of the plywood. Question 2. What causes the wooden block to move when the plane is being tilted? There must be a force acting on the object that pushes it downwards along the plane. Question 3. How do you think this happens? An object placed on a tilted surface will often slide down the surface. A tilted surface is called an inclined plane. The rate at which the object accelerates down the surface is dependent upon how tilted the surface is. The greater the tilt of the surface, the greater the acceleration of the object down the slope. Objects tend to accelerate down inclined planes because of an unbalanced force. The normal force always acts in the upwards direction, opposite to the direction of the force of gravity. This is true when objects are placed on horizontal surface. On a flat plane, the perpendicular component of force of gravity is directed opposite the normal force and as such balances the normal force. But normal forces are not always acting upwards, but rather they are always directed perpendicular to the surface that the object is on. On an inclined plane, assumed to be friction-free, the normal force does not act directly opposite to the direction of gravity. Usually, any force, a vector quantity, directed at an angle to the horizontal can be resolved into two or more component forces. Here, the force can be broken down into two components, that is, the horizontal and vertical components. The force of gravity here is resolved into two component forces, one directed perpendicular to the inclined surface, F perpendicular, and the other directed parallel to the inclined surface, F parallel. On an inclined plane, the force parallel to the inclined plane is F parallel, which is the parallel component of the force of gravity. This force is not balanced by any other force. Thus, the object will subsequently accelerate down the inclined plane due to the presence of an unbalanced force. It is the parallel component of the force of gravity that causes this acceleration. The parallel component of the force of gravity is the net force. In the presence of friction or other forces, the situation is slightly more complicated. The perpendicular component of force, F perpendicular, still balances the normal force since objects do not accelerate perpendicular to the incline. Yet, the frictional force must also be considered when determining the net force. As in all net force problems, the net force is the vector sum of all the forces. That is, all the individual forces are added together as vectors. Now, let us watch another scene of a family moving into their new house. What can you suggest to help the mover unload the goods easily from a fixed height? Let's find out more in the next activity. Now work in groups of 4 and conduct an experiment to find out the relationship between the angle of inclination of a plank or plywood and the force exerted on the load. Each group is given a few pieces of plywood or wooden plank of lengths 0.5 meter, 1 meter and 1.5 meters, a spring scale, 5 pieces of bricks, a plastic bottle filled with sand to represent the load, and some strings. Please answer these questions. Question 1. What are the forces acting on the plastic bottle filled with sand when placed on the inclined plane? Question 2. What will happen to these forces when the angle of inclination on the plane is increased? So what are the forces acting on a plastic bottle filled with sand on an inclined plane? These forces acting on a plastic bottle are the horizontal component of the force of gravity on the bottle and the tension in the spring. So question 2, what will happen to these forces when the angle of the inclined plane is increased? These forces will increase accordingly. So this experiment shows that by increasing the angle of the plank, the home mover can slide the object down easily. The variation in the angle of inclination of an inclined plane can affect the force exerted on the object placed on the plane. As the angle of the inclined plane is increased, the force on the object along the plane is increased. As the angle increases, the component of force parallel to the inclined plane increases and the component of force perpendicular to the inclined plane decreases. It is the parallel component of the weight vector that causes the movement along the plane. Thus, the force on the object is greater at greater angles of inclination. Based on what you have learned on resolution of forces, what can you suggest to help Joe move the traveling bag with ease? Let's find out in the next activity. You are provided with a traveling bag with 2 wheels. Work in a group of 4. Collaboratively find out whether it is easier to push or to pull a traveling bag on an uneven surface. Perform the experiment, discuss and present your answer to the class. Now, have you found out whether it is easier to pull or to push a 2-wheel traveling bag? Yes, it is easier to pull rather than to push a 2-wheel traveling bag along an uneven surface. Well, in this lesson, we have seen that the resolution of forces on objects is a common and widely applied concept. We've identified forces acting on objects and its resolution of forces related to our daily activities, like when objects are pulled at different angles or when they are moving down along planes of varying angles. You can also relate the concept of forces resolution in daily activities around you. For example, the forces acting on the handle of a garden lawnmower when mowing the lawn, and a snow skier moving down a slope. The force on the handle of a garden lawnmower when mowing the lawn. When a lawnmower is pushed, it does not move in the direction it is pushed. It moves in the direction parallel to the surface of the ground. The force that acts along the handle at an angle to the surface of the ground is resolved into two components. One component acts horizontally and moves the mower along the ground. The other component acts vertically and tends to push the mower into the ground. The force exerted on a snow skier moving down a slope. Here, the force of gravity, that is the weight of the skier, will be resolved into two component forces. One directly perpendicular to the slope, W1, and the other directed parallel to the slope, W2. If the parallel component of the weight of the skier is balanced by the frictional forces on the ground, the skier stays stationary. But if the frictional force is less than the parallel component of the weight, or if the skier pushes himself forward with the ski, then the resultant force will subsequently cause the skier to accelerate down the slope. It is the parallel component of the force of gravity that causes this acceleration. The parallel component of the force of gravity is the net force. We hope that after following our lesson, you have understood some concepts of forces and angles and relate it to familiar activities around you. We wish you all the best and thank you for using Blossom's video lessons. Hello there! The context of this video is in Malaysia. However, you are welcome to adapt and adopt the activities according to your context or similar daily applications. Please note that this video is to help students of ages 15 and 16 understand better about the resolution of forces and learn how to draw free body diagrams. Students should have the knowledge of trigonometry, so you need to do some revision on simple trigonometry to enhance students' problem solving on resolution of forces. Most of these materials required for the activities are very simple and can be easily made available. You have to guide and encourage students to explore new ideas during group activities. Materials and apparatus required for It is hoped that students will enjoy learning and constructing new knowledge through this inquiry-based learning approach.